Both men and women are equipped with reproductive organs, each perfectly designed for one extraordinary purpose: creating new life. Inside a woman's ovaries are about 500,000 immature eggs, each tucked away in tiny sacs called follicles. Every month, a handful of these follicles begin to develop, but usually only one becomes dominant. As it matures, it grows to around 2 centimeters. When the time is right, that egg is released in a process called ovulation. The finger-like ends of the fallopian tube sweep in to catch the egg, guiding it gently inside. Now, this egg isn't unprotected. It has 2 key outer layers, the corona radiata on the outside and the zona pellucida just beneath. If a sperm wants to enter, it must break through both of these barriers to reach the egg's core, the nucleus, which holds 23 chromosomes. These chromosomes are made of DNA, the instruction manual of life. It decides everything from your hair color to how your heart is shaped. But if something goes wrong during this step, say, an extra chromosome is included, it can lead to genetic conditions, like trisomy disorders. Once released, the egg begins its journey through the fallopian tube. Tiny hair-like structures called cilia, along with muscle contractions and mucus, help move it along. Meanwhile, thousands of sperm are racing from the opposite direction, drawn in by chemical signals released by the egg. Each sperm carries 23 chromosomes from the father. Its mission is simple but challenging: reach the egg, break through its defenses, and merge with it. When one lucky sperm succeeds, it sheds its tail and outer covering, revealing the genetic package inside. This sperm fuses with the egg, and almost instantly, the egg blocks all other sperm from entering. Right then, something amazing happens. The egg completes its final stage of maturity, prepping its own nucleus for the ultimate union. The 2 nuclei move toward each other, each carrying half the genetic blueprint. When they merge, the first cell of a new human is formed. This single, powerful cell is called a zygote. From here, life begins to divide and multiply. The zygote splits into 2 cells, then 4, then 8. Eventually, it becomes a compact cluster of 16 to 32 cells, known as a morula, a little ball still wrapped in its original protective shell. Then comes a transformation. Fluid begins to fill the center of this ball, forming a hollow structure called a blastocyst. Inside, 2 distinct parts appear: the embryoblast, which will become the baby, and the trophoblast, which will form the placenta and support systems. At this point, fertilization has already occurred back in the fallopian tube. Over several days, the blastocyst makes its way to the uterus. By the time it arrives, the uterus lining has thickened, ready to receive new life. The blastocyst hatches from its shell, and like a seed finding fertile ground, it burrows into the nutrient-rich wall of the uterus. This is called implantation. If you looked closer, you'd see the uterus lining full of blood vessels and glands, ready to nourish the embryo. The outer layer of the blastocyst begins to fuse with this lining, forming what's called the syncytial trophoblast, a structure that will help support and feed the embryo. Soon the embryoblast splits into 2 layers: the epiblast and the hypoblast. Then, the amniotic cavity forms. This will eventually surround the baby in fluid. Next comes the yolk sac, another temporary support system. The embryo is now tucked securely into the uterus, with a small wound at the implantation site. Sometimes, this causes light spotting known as implantation bleeding, a natural and harmless part of the process. As development progresses, more structures begin to form: the chorionic cavity and a connecting stalk, which will later become the umbilical cord. Now we enter week 3. The blueprint of the body begins to unfold. A process called gastrulation begins, creating 3 foundational layers: the ectoderm, mesoderm, and endoderm. These are the master layers that will become every part of the human body, from skin and nerves to muscles and organs. At the same time, another key development begins: neurulation. This is the very beginning of the nervous system. A shallow groove forms and folds inward, eventually sealing into a tube. This will become the brain and spinal cord. Tiny bumps called somates appear alongside this tube. These are the early building blocks of your bones, muscles, and skin. These cells will soon form the networks that allow us to move, sense the world, and think. By week 4, the transformation continues at lightning speed.